This lecture will go over ionic and net ionic equations. You are going to want to have your solubility rules sheet out for this because we are going to be using those as well. But just like with the previous quiz on predicting the products, you will get to use those rules. You do not need to memorize them, just be able to use them. All right, so ionic and net ionic equations are going to be used to show what reactions are actually occurring within the reaction that we're looking at. So there are some things that as we go through the reaction, they're just kind of there. They're what we call spectators, and we'll get to that in a second. But at the end, what we're going to see is what reaction is actually occurring to give us a new substance. So the first thing is a molecular equation. So what you've been writing already up to this point, when you've been writing a complete equation and you've been balancing it and you've been including your states, that is your molecular equation. So what you've been doing so far, that's the molecular. The next type of equation is an ionic equation. This is when what we're going to do is we're going to take that equation that we had, the molecular one, and we're going to break it apart into the individual ions. Whether it's a polyatomic ion, or it's a cation, or an anion, we're going to break it apart into all of those separate parts. That's the ionic equation. Then we have a net ionic equation. And that is what is left over after the spectator ions are removed. So before I explain the net ionic, let's talk about spectator ions. So spectator ions are ions that are the same on the reactants and the product side. So let's say I had an Mg plus 2 on my reactant side. I have some other reactants. And then on my products, I also have an Mg plus 2, and then I have other products. Then this magnesium is a spectator. It is on both the reactants and the products. So what we're going to do is we're going to remove that from our overall equation. So what we'll be left with is this net ionic equation. So if any of you've had paychecks before, so you have a job, so you get that tells you what you got paid, and then all those taxes come out, and then you have something that's called a net pay. That net pay is what's left after everything, like your taxes, have been removed. So same thing with a net ionic equation. It's what's left after our spectator ions have been removed. So you can think of those spectator ions as being your taxes. All right, so steps to doing this whole process. The first thing is we have to write a balanced molecular equation. Now, the problems that I give you in this lecture are already written and already balanced. That doesn't mean that I can't ask you something that's, I give you the reactants and you have to predict the products, and then you have to predict the states, and then you have to balance it. So all of this stuff you've done in the first two quizzes is going to tie together in this one. So don't expect for questions on the quiz to look exactly like the ones in here. I've just skipped the steps that you've already done already. All right, so step 2 is to break it apart into ions. So if I have something like Na3PO4, so what this is that's my compound. So if I were to break that apart into ions, my ion for sodium would be Na+, my ion for phosphate would be PO4 minus 3. And the other thing is we have to include this number, so I actually have 3 Na pluses. So we're going to get practice doing this, but that's what I mean by breaking apart into ions. Now, solids and liquids are not going to break apart into ions because they are not aqueous, therefore they are not going to dissolve. So what you do with something that is aqueous, or not aqueous, if we're looking at this one too, you're just going to leave it as it is. So anything that would come out as insoluble, you are going to leave it as is. Then you're going to determine the spectator ions, the ions that you saw on the reactant side, the ions you saw on the product side. You're going to remove them, and then you're going to be left with only the reacting ions, so we can write a net ionic equation. So this is when you're going to see what's actually occurring or what's actually reacting in the problem. All right, so let's go ahead and do some practice problems here. All right, so we have sodium phosphate plus calcium chloride plus sodium chloride sodium chloride plus calcium phosphate. Now, I have already written in, I've already balanced everything, I've written in your states, so you do not have to do that. But make sure that you are comfortable with that. So that's step 1 already. Step 1, done. Step 2 is to break apart into the individual ions. So, that's an ion. That's an ion. Calcium is an ion. Chloride is an ion. Sodium is an ion again. Chlorine is an ion again. Calcium and phosphate. So those are all of our ions. Now let's write them out. So sodium we know is Na+. Now how many sodiums do we have? Now what you're going to look for, we have 3 from the subscript here, and then we have 2 from the balance, which gives us a total of 6. Okay, and that is being added to phosphate, which is PO4 minus 3. And then how many of those do we have? We have 2. And then we're adding that to our calcium here. Remember, calcium is a +2 charge. How many calciums do I have? I have 3. And then chlorine. Chlorine is Cl-. And then how many do I have? I have 6 because I got 2 from the charge, 3 from the balance. It's going to give me a total of 6 of them. Okay, so all I did was break everything apart into ions. So that's our reactant side. Now we'll do our product side down here. So looking at our sodium first, I have 6 Na+. And then we move on to our chlorine. Remember, this distributes out. So now I have how many chlorines? I have 6 Cl-. And now, what's happening here? This is a solid, so it is not going to break apart. So I'm going to be left with Ca3PO4 2 as a solid. All right, so now let's look at our spectators, things that cancel. 6 Na+, 6 Na+, 6 Cl-, 6 Cl-. So before I cross those out, that was our ionic equation. Okay, so we have our molecular up top, and then we have our ionic equation with step 2. Now we're removing our spectator ions, the ones that are on the reactant side here and the product side. So now to write our net ionic equation, we're going to write everything that is left. So what am I left with? I'm left with 2PO4 minus 3 plus 3Ca plus 2 yields Ca3 PO4 2. Okay, and that is your net ionic equation. So step 1 up here, writing your first one. This was step 2. And then here was our third equation. All right, moving on. All right, so our next one. Once again, this is a balanced equation for you. So we have barium chloride plus sodium sulfate gives us barium sulfate plus sodium chloride. So first step is already done for you. Now we have to write our complete ionic. So we're going to break this apart into our different ions. So we have a barium ion, we have a chloride, we have a sodium, and we have a sulfate. So then looking on the other side, we've got a sulfate, we have barium, chloride, and we also have sodium. All right, so now we see all of our parts here. So step 1, done. Step 2, write this out into their separate ions. So barium is 2 plus, so that's going to be Ba plus 2. I only have one of them, no coefficient in front there. Plus 2Cl minus, that came from our subscript, plus how many sodiums do I have? I have 2. And then we are left with the SO4. So there's our reactant side. Now we'll do our product side. So first thing we have there is barium sulfate, but what do we notice about that? It's a solid, so it's not going to break apart. So we keep that. But our sodium chloride is going to break apart, so let's include that in there. 2Na plus. Now remember that 2 in front as the coefficient is going to distribute out. 2Cl minus. All right, so that is step 2. That's our complete ionic equation. Now, got to cross out those spectators. I have a barium on the reactant side. My barium on my product side is tied up in that solid, so I can't get rid of it. 2 chlorines or chlorides on the reactant and on the products, I can get rid of those. Sodium can get rid of those. Sulfate on the reactants, sulfate's tied up on your products. All right, so that now we're going to combine everything to write our complete or our net ionic, what we're left with. Okay? All right. One last one. All right, what I want you to do, this is already balanced for you. I want you to go through and I want you to divide it up into, I want you to write out the complete ionic equation. Once you've written the complete ionic, come back and we'll finish the rest of the problem together. All right, so here's what you should have for your complete ionic equation. So everything broken apart with their charges. Now let's go through and let's start getting rid of our spectator ions. Calcium, calcium, chlorine, chlorine, magnesium, magnesium, nitrate, nitrate. Okay, what happened? Everything canceled. So what we say in this situation is there is no net ionic equation. Okay? So that is a possibility. Don't freak out if you look and see and everything canceled. Okay? Go ahead, work on those practice problems. Write out your molecular first. Make sure that it is balanced. You have to balance your equations first. Okay? Then write your completes, identify your spectators, cross them out, and see what you are left with. Good luck.